This conference will now be recorded.
All right. So we're going to have Shiva Kumar present on a contribution that they're also going to present at the Global Summit on DDC v3. So Shiva, I'm going to make you the organizer. Hopefully that gives you everything you need. Are you able to present now?
It did not give me authorization. No. No.
So I had already given him presenter rights. It should be at the top of your screen.
So can you just give me one more time authorization, like presenting rights?
Hey, Shiva Kumar, you show as being the presenter right now. Across the top of your screen, there should be a share my screen button.
It's actually at the bottom. It should be at the bottom. Mine's at the bottom.
Oh, yeah.
So on the bottom, I see my camera screen and leave.
Yeah. Click on the screen.
Okay.
Yeah, you should have mic, camera, share, and then leave at the bottom.
Okay, I think it's now working.
Yeah, it is. We can see it.
All right.
Yeah.
So one question before it. So how much time I have?
You have the whole meeting because the MyTech team wasn't able to present, so you take as much time as you need.
All right. In that case, since it is a combined meeting, right, to the telco as well as incubation committee meeting, so I will cover this, and also I'll ask my partners to come in and then talk about their presentation. Yeah.
This is not an IC meeting. This is the telco edge group. So this is the telco group meeting, not the IC meeting. That'll be coming up the next meeting, maybe a month from now.
Okay, no problem. We'll present it again to that IC meeting also. Okay.
Yes. Yes.
Thank you. All right. So today I'll be presenting DDC version 3 base specification. So we have many people who contributed to this, at least from different organizations. AT&T, of course, and UFI Space, Intel, Dimet, HPE, etc. All the people are listed here, and I will ask my partners to chime in and then provide some more information appropriate time. Mainly, I'll be speaking. If I need my partners to talk about that particular slide, they're free to do so. So, in this slide, I'm going to cover what are the main reasons for DDC version 3. I mean, from DDC version 2, already we presented to OCP. What changes are major highlights, etc. So, basically, it's a capacity increase from, currently 192 terabits large cluster to 922 terabytes, because we're using the latest Jericho 3, Raman 3, etc. It gives us an ability to go to that capacity. So AT&T is backbone is really trying to do this in near future, not because we are exhausting the capacity, but the port exhaust is happening. That is the main driver. When we do that, we are trying to go use the latest Broadcom chip and then trying to achieve that goal. When we do that, we definitely need interoperability with the existing cluster, 192 terabyte cluster, and also if at all we use only the latest and greatest boxes, we can go up to 922 also. So I'm going to go to the details of the particular SKU later on, but at the highlight currently and what I'm highlighting is there are two SKUs we are doing. Just because we don't know how the industry is going to transform, whether to use QSFP-DD or OSFP, right? So depending on what picks up in the industry, we are going to choose that. But currently, both SKUs are being manufactured. And if you recall, old Jericho Ramon, what we used, we didn't have the timing capability, but with now Ramon 3, new PTP and IEEE support exists, so we can do the timing support also. Apart from this, there are some NOS features also we need to do it, which can take care of all these hybrid situations, and also new NOS feature enhancements, etc. We'll cover that in a later slide, and then I think I have a DevNet partners also to go over that with you guys. We also going to upgrade our NCC from current Gen 10. We are using currently the HPE that is a Gen 10. We are going to migrate from Gen 10 to Gen 11. So details will be followed in this deck for that. And multi-updater functionality currently exists, but we're improving on that to really give more facility, more feature like SSD firmware upgrade facility also. So I'm not going to describe what is a DTC because it's all well known and things like that. Any questions on this? Okay, moving on to the next. So this slide is really going to depict mainly the differences between our previous versions, version 1, version 2, and now version 3. So 2023 is the version 3, what we're presenting, 800 gig support, and NCF, and timing functionality, etc. Whatever I told in the previous deck, already covered. Also, along with that, we are trying to use Intel Ice Lake with the VROC functionality in the white box itself. This VROC functionality we are going to cover in the later slide, but our partner Intel is going to go over that slide, I guess. Mainly for white box as well as the HPE units, we want to promote Redfish functionality along with the current legacy IPMI also. Moving on to the next slide. So this is our compliance tenants, OCP tenants. Basically, I'm not going to go line by line, but in the previous large GMUX presentation that I made, there was a request to add the power usage in terms of bits per wattage. So we do have for Jericho 2 some value. Kai, maybe, I'm using this, so whatever is there down below in the note section. So Jericho 2 had 0.0129 bits per watt. Jericho 2C Plus at 0.018 bits per watt. Jericho 3 provides 0.02 bits per watt. So that is what we are going to really using Jericho 3 and Ramon 3 we are going to get. I don't know whether that's how you wanted it in the OCP, but we can redefine this later on if this is not sufficient for you then.
Yeah, thank you. If I can add a little bit more from what Shivakuma said, I'm from UV Space representing the hardware side. So version 1 is based on Jericho 2, and now we have a version 3. This is based on Jericho 3. J3 is a 5 nanometer chip, and then versus J2 is a 16 nanometer. When the nanometer, the gap of the wafer gets smaller, by design, it consumes less power. So what Shivakuma was showing is the processing capability per watt that is consuming. So even though the overall, because we are also increasing the port density with the J3, now we are focusing on high density 800 gig. But the key takeaway is the three numbers Ifukuma just mentioned, is the processing power per per watt that is consuming. That number continue to come down, and a lot to do with the physics of the chip itself. Now we are working with a 5 nanometer chip compared to a 16 nanometer. That's also one more in between the J2C plus, which is not part of the presentation today. That one is a 7 nanometer. But I just want to show the idea, the gap of this our silicon wafer continue to come down, and resulting the benefit of consuming less and less power that Sivakuma just talked about. Back to you, Sivakuma.
I have a
Thank you,
quick
Kai.
question. So
Good.
in the previous slide, you mentioned promoting Redfish and IPMI, and how are you doing that promotion?
Can you repeat the question again?
Yeah, on this slide, you mentioned promoting the use of Redfish and IPMI,
Yeah.
and I'm
Yeah.
asking, how are you promoting it, and is that going to be discussed here or later on?
So how I'm promoting means actually we have HP representative and also in the white box. So from the white box we cover. So we need all the currently white boxes. What we have done supports IPMI commands, right? So along with that legacy IPMI commands, we want the new Redfish command to be supported. Open BMC thing on the white boxes, but on the NCC directly, NCC guys are able to support both of them. Does it answer?
What do you mean? What do you mean able to support?
Yeah.
No. What do you mean by able to support? You just have a
Kumar, this is
BMC
Rodney
setting
from
it?
HPE. Do you want me to jump in on this one?
Yeah, go ahead.
Okay. Yeah. So today, this is Rodney from HPE. So we support through our BMC. It's our integrated lights out, also known as ILO. Supports both IPMI and Redfish. Now, when we go back in history, IPMI used to be the method of collecting information from the BMC. Redfish API eventually came to fruition, probably going back to our ILO 4. Currently, we're on ILO version 5. So we probably have about 7 years or so since we introduced Redfish as a new way of interacting with the BMC. As we've progressed forward through what AT&T is currently using in our Gen 10 product, with ILO 5 and moving forward into our next generation product, Gen 11, Redfish is becoming more predominant. IPMI is more of a legacy tool and legacy API. There's some security concerns with IPMI, so from an HPE standpoint, we are transitioning to using Redfish as the primary method of interacting with the BMC, and IPMI is not being deprecated. We're going to support legacy commands through IPMI on Gen 11. However, new features, new development for interaction with the BMC will be via Redfish. And that's why we're suggesting additional development for network operating system, et cetera, be done with Redfish for collection of health status parameters, power supply information, inventory information, et cetera.
Okay,
Does that
thank
answer
you.
your question?
If
Okay.
I had known there was an HPE under the cover, I wouldn't have to ask the question. I work very closely with Jeff Cohen.
Oh, got it. Okay.
Thank you.
Sure.
Yeah. So since Rodney, since we've already talking about the HPE thing, so I brought up this slide. So why don't you cover this slide also along with the Redfish? What are the other changes from Gen 10 to Gen 11 you can cover?
Sure, I can do that. And just a little background. So AT&T has been using our DL380 Gen 10 server as the NCC or DCC, whatever you want to call it, the network controller function in the DCC design, or I'm sorry, in the DDC design. And they started with Gen 10, which initially started with Intel Skylake processors. Currently, they're using Intel Cascade Lake. That was the follow-on to Skylake. Those go up to 28 cores, but I think they're using something a little bit less than 28 in their current configuration. When we get to Gen 11, which is available today, up to 60 cores in the Intel Sapphire Rapids, which will be in our DL380 Gen 11 product. PCIe, the number of lanes in Gen 10 was 48 lanes. In Gen 11, we go to 80 lanes. And we go from Gen 3 in Gen 3 PCIe to Gen 5. So you're seeing a major increase in throughput in the PCIe lanes from Gen 10 to Gen 11 in our servers. And that's an industry standard architecture. So this is not specific to HPE. So that's a PCIe standard. The memory channels, we're seeing an increase from 6 DIMMs per channel to 8 DIMMs per channel, so you have more memory bandwidth. DDR4 to DDR5, so DDR5 is a 2x increase in memory bandwidth over DDR4. And we see the support of additional NVMe type storage, which is not necessarily what's used for the DDC design. Right today, storage is pretty much standard SSDs, but NVMe is available with increased Gen 5 NVMe capabilities in our Gen 11 product. We have additional power supplies to handle the uptick in more cores, more CPUs, more memory, more NVMe, all of the components that add to the power demand. So we have additional power supplies to handle that demand. Probably not applicable here, but we do have some specific air and hybrid cooling solutions to handle the higher wattage processors and devices. And then, as I mentioned earlier, our management engine, what we call the ILO integrated lights out, which is the BMC, goes from ILO version 5 to ILO 6. And in ILO 6, basically we add support for all of our new products. Any additional features, functionality in the BMC get incorporated into ILO 6. So we've added a couple new features. If we need to go in depth on that, can certainly cover that at another time. But just know that as I was talking about Redfish, we've seen an increase in enhancements of Redfish support. We published to GitHub our schema, and you can see the features and functionality through GitHub. And ILO 6 has some of those enhanced features using the Redfish API. Any questions on this? Okay. I'm working with Shiva Kumar and the AT&T team in terms of what they're going to be looking at for the evolution of their current NCC from where they're at today to what they're planning to do for the future. So looking at the Gen 11 server as what they want to potentially deploy in their DDC architecture.
Thank you. Thank you, Rodney. So any questions to Rodney? If not, so I'm jumping around. So what I'll do is from Intel, do we have Intel representation? Felipe, are you there?
Yes. Good afternoon. Good morning, everybody.
Yeah. So why don't you cover the Intel virtual RAID functionality, VRAM functionality, which is really absorbed in not only in the white box but also in the NCC that HPE we already gone through. So can you please give us some brief on this functionality and the benefits of this?
Absolutely. Thanks, Shiva Kumar. So on the bottom left, you basically have the representation of what Intel VROC brings to bear. Traditionally, when redundancy has been required around storage, companies have either installed a husbus adapter or maybe a RAID controller chip down on the motherboard that are basically connected over PCI Express to the main processor and provided a NVMe connectivity to external drives. What Intel VROC does is that we are taking the functionality to enable a RAID across different drives. We have a number of ingredients within our Ice Lake processor, which is at the heart of the AT&T design. It's signaled as an Intel VMD within the diagram, which basically allows for direct connectivity from the processor to a number of drives, and through extensions that are incorporated to the BIOS, a RAID volume is actually presented to the OS, to the kernel. So the BIOS extensions will take care of all the translation between calls coming from the kernel to the RAID 0 or RAID 1 or RAID 5 volumes. It will take care of events, hot plug events on those drives. It will do rebuild of those volumes. So in a nutshell, when you compare different solutions for storage reliability, in the top bottom right hand corner of the slide, you have hardware RAID, which would be represented by the external husbus adapter. We have Intel VROC, and some people have been taking advantage of Linux software RAID solutions. Basically, Intel VROC requires less hardware, as is obvious in the diagram, increases reliability, but increases reliability in a way that even when the drive that hosts the OS kernel fails, VROC is going to be able to switch to the redundant drive, something that software Linux would not be able to do. So provides upgradability, handling error isolation in a way that the OS doesn't need to handle drive failures, provides boot support, as I explained already. And as a result of the architecture, it helps with lower power. So we think that this is, from a storage perspective, brings simplicity and increases value to AT&T in their solution. We gave on the banner on the top of the slide, we gave some indicators around better IOPS for this solution, reduced latency, because our software solution is more elegant. There are less translations that are required, and that we are more power efficient. So there's a OPEX component that brings additional value. Any questions, anybody?
So
back to you, Shiva Kumar. Thank you.
Felipe, so probably you said this, I'm just trying to reiterate in that arrow, what I'm showing, this extra electronics to do all the RAID functionality before need not be there. You can eliminate this potential thing, and then directly you can use the Intel architecture to directly connect to the SSDs, right? So this is not at all needed.
Yes.
I'm just highlighting what you said.
Yeah, thank you. Thanks very much.
All right. So if no questions to Intel, I'm going to now.
Just a quick question. Is there a special driver that's needed for, like, say, a Linux utilization for this?
Yes, there's an MDM driver that was upstreamed many years ago. So it's part of almost every distribution of Linux that exists today. So Linux is going to be able to discover the VROC volume when that VROC volume is presented to the OS by BIOS, and it will be loading the right driver to be able to consume that volume.
Okay, so there's nothing special other than MDM that's needed.
Correct. It's all mainstream. drivers that
Okay.
are basically utilized to implement this solution. Good question. Thank you.
Thank you.
Yeah. So also, Felipe, the clear details about all the drivers and the internal architecture, etc., what needed for this change, in detail will be covered in our specification document, right? In the Word document, we are going to have a architecture diagram about this, right?
Exactly right. Yes. Thanks. Good point.
Yeah, we're going to cover that, but it exists because it's already too many slides deck. We don't want to cover everything here. It is impossible. So I just put the highlight here to talk about it. But our Word document-based specification will have more details how to use. All right. So thank you, Felipe. What I'll do next is I'm going to keep the OFE part of it, the box design to the last. But before that, I really want our partners, NOS partners, to talk about what other things they're trying to cover, etc. So do we have Ran?
Yeah, I'm here.
Please, can you cover 16
Yeah, of
and
course.
then give us, there is no time limit as they said, so you can talk and then later on I will go back to the hardware part of it.
Sure. I don't have a lot to cover, so I would not consume too much time. Essentially, anything to do with DDC goes hand in hand, hardware and software. It's a disaggregated model, and hence the software companion is kind of inevitable. Whatever was mentioned already by UV Space, HP, and Intel, and other partners as well, we're working hand in hand. The software needs to cater for all of this. So what we're looking at now, in this case, the timing support, everything to do with support for the timing protocols within the silicon. That's a new kind of insert with Jericho 3 Ramon 3. Obviously, the distribution of timing through the fabric is another element which was added in this version of the spec. The support, obviously, for the new ASICs, it brings in capacity. It brings in some different topology a little bit. The support for obviously scale as it comes. J3 and Ramon 3 are boosting the scale. And then because we're introducing a new generation of silicon, there is a new formation which is potentially now a possibility of hybrid clusters, such clusters that involve different versions of NCP. I think we had that in version 2 of the spec as well, when we had J2 and J2C+, it coexist within the same cluster. In this case, we have ASIC generations within the same cluster. So there is inherently in the silicon side, that's on the Broadcom side, backwards compatibility on the SerDes speed. So you can connect a Ramon to a Jericho 3 or Ramon 3 to a Jericho 2. That mix and match does work. Obviously, there are some practicalities that we need to adhere to in terms of what kind of topology eventually you end up with. So I wouldn't say that there is any limitation to any specific topology, but there should be some sense in building it, right? It doesn't really make sense just to build theoretical structures. So whatever is practical, obviously, is also doable. And again, this is derived from the silicon capability, and the NOS then caters for the overall, say, overarching software that control all of these components and builds them out into a single unity. And hence the variance of different devices and different silicon is bolted into the NOS itself. One thing which is not really covered within the DDC spec is the software functionality. The actual features of the router eventually are not really described, are not part of the spec. It is, by definition, or to begin with, was implementing a core router functionality as well as a peering router functionality. Those were the first two. Aggregation router was later added, and now we are adding an edge functionality. So anything to do with tunneling, layer 2 OEM, segment routing, we're boosting the logical scale of eventually the resulting router. And again, this is an edge functionality. Again, this is not part of the spec, just additional features which are being added according to customer demand. It is worth noting that in parallel to the OCP, there is TIP as an organization which is also adopting kind of the same type of topology. It's not called DDC, it's called DDBR, but it's essentially the same thing. And TIP does define the software functionality. So there is a TIP compliancy for core router, peering router, edge router, and so on. So there's kind of a, I wouldn't say overlap, because they really actually complement one another, TIP and OCP in this case. And then to conclude, one thing which apparently is a potential application to run on top of a DDC is not just to implement the entire DDC as a single standalone router that exists in a telco network, but to build a larger scale of a DDC, and then every endpoint or every network port of that DDC is then connected to a GPU or a server for that matter, and then you have kind of a data center topology connectivity architecture. This is still in the making. There's not a lot of make from the software perspective. Essentially, it's the same architecture, it's the same topology, just much bigger. So we're working on that angle. Not sure if this is valid content for the DDC version 3. Might be more aligned to DDC version 4, but this is kind of work in progress that is still kind of in the making. That's it from my end, if unless there are more questions.
So, Ran, you're right when you said that all the features are not depicted here, because this is basically the OCP. We were only focusing on the disaggregation piece. We were not covering all the requirements of the NOS, but including the upgrade portion also. So because we covered in the version 2, we are not covering the upgrade functionality here. But what I wanted to convey, apart from what Ran said, is not only the one what you're seeing, yet functionality listed here, what you see. Apart from that, you do have the capability for all the features of the NOS, for the P-leaf and the peering, etc. It's a big list. Everything is supported. But if somebody feels that it should be listed in the Word document, like a base specification, we can just list them out. But there's a big list of features they support.
I was making a complaint, Shivakumar. I was just making an observation. And
correct. Absolutely. I'm just making it clear to people. If they want, we can list it, but it is very complex, and then it is listed somewhere else, not as a part of this. I was trying to tell the team here. Yeah.
Mm-hmm. Yep.
Any questions to our NOS partner? Hey, thank you, Ran.
Sure.
So I'm going back to the OFI portion of it. So Kai,
Yeah,
over to
sure.
you on your HCP5 router.
Sure. Okay. So what we are showing on this picture is the front panel of the NCP5. For those of you just on the acronym, is Network Cloud Platform. It's basically the single line card function that uplink back to the Fabric, the Ramon chipset. So the fifth NCP that we built from NCP1, this one is based on the Jericho 3, and it's focusing on, if I can call your attention to kind of on the top, where all the service port is focusing on high density 800 gig as well as 400 gig for breakout for those that may be needed. This one for the non-blocking. First of all, just for the audience background information, J2, when we first built the earlier version of the DDC, J2 is a 4.8 terabit per second. And then the J3 is basically 14.4. All right, so that's why we can fit all these 800 gig port, 18 of them to be exact. on top and be able to preserve the non-blocking. We color code the devices on the left where all the blue, and this is consistent with the previous generation of all the DTC. The blue are the network port which they talk Ethernet, either regular Ethernet or jumbo frame or whatnot. The one on the right hand side with the different purple, with the red color on the right hand side, those are the fabric port, and those are standard with the 800 gig uplink to the remote fabric doing the switching. And then last but not the least, you see some other peripheral port on the left side. Those are the management, and then the console port and all these housekeeping thing. One thing I do want to elaborate what Shivakuma said earlier about the improvement of the timing in some of the previous version, like J2. Now, for those of you who actually are interested on the backend architecture, when we plug in Ethernet devices into this Ethernet port, the Jericho device actually chop it down into cell switching. So it's uplinked into the cell switching on the remote, and then coming back down on cell switching to another Jericho devices, which they put all the cell together into a Ethernet frame. That is called fragmentation and reassembly. That process in J2 in the older generation cannot deal with the PTP, the precision timing protocol. And now with the improvements Shivakuma talked about earlier, this newer generation doing the fragmentation and reassembly, the latest silicon are able to deal with the PTP precision timing protocol going through the Ethernet network. So that is kind of a little bit under the hood how Broadcom has made an investment on that one. The last but not the least, this box, maybe Suvakuma, you can go to the block diagram and I can talk about the 4 different processors. Yeah, this one.
Yep.
Yeah. So thank you. So question?
Just maybe a question on the previous slide there.
Sure.
The micro USB port there, is that just like for firmware upgrades, or what what can be done with that?
Yeah, that could be one. Although Suvakuma earlier mentioned we have something called the multi-updater. Multi-updater
Yeah.
is is an open standard based on only the open environment installation. So we tend to use the only, but the micro USB can do that. But and John, honestly, more or less because it was there from version 1, and then we just
Yeah.
kind of leave it there for
Okay.
backward compatibility purpose. But to answer your question, firmware update and all that, we are now using a standard open tool called the multi-updater based on only the open network install environment.
Correct.
Okay, thanks.
All right. Thank you. And then to the block diagram, pretty quick. They are just like some of the previous generation of the DDC. This particular latest version 3 continue to follow the same architecture in parallel. Has 4 different processors on this, and we color code them when we supply this block diagram to AT&T and other folks on this call. The blue right in the middle, that's the J3, and then that is the data plane that basically do all the packet forwarding, and then it takes the instruction from the control plane, which is on the left upper corner, and in this case is the Intel Ice Lake. That's where all the intelligent run from DriveNet talk about the code they are developing. So that goes into the control plane and give instruction into the data plane, how they actually forward. And then if you can see the data plane actually connecting on the bottom with all the I/O. So those are the data plane and control plane processor. 2 more processor on this I'd like to share with the audience. One is the smaller one on the left middle. It's called the BMC. The AST is a processor for the broad management controller. And basically that is done to do all the health check with all the boot up sequences and all the housekeeping. So we do not bother the x86 for those overhead. That's a separate processor. That's the third one. And it's kind of like a distributor architecture if you think of it that way. And the last one is the green one on the right-hand side. And this one is our timing module. And the timing module is based on the engine from Microchip, Microsemi. And then we also have some in-house developed FPGA programming. And the reason we need the FPGA programming is once the and for those of you who are very interested in the 1588, that's a concept called the servo. Servo is the engine that actually did all the calculation. And once the servo is being processed, we had to translate that format, the data format output back to the Jericho 3 that the Broadcom chip can understand, and is being do so by using a FPGA programming inside the green box, do the format translation. And UV Space, we developed that data format in-house by leveraging the microchip, micro-SIMI timing on the PTP support and whatnot. All right, so those are the 4 different processors as kind of like a high-level overview. I'll stop here, Suvakuma, if anything you'd like me to talk about.
No, so this you talk covered about HCP. If there is no question, you can cover NCF also.
Sure. Okay. Thank you. So this is the next generation of the NCF. Just for the audience background information, the nomenclature could be a little bit confusing, so I like to spend 30 seconds to talk about this. So originally, a few years back, Broadcom came up with the switching fabric called the Ramon, and then later on they have a Ramon 2. And this box you're looking at is a Ramon 3. Okay, we are skipping the Ramon 2. At a high level, the reason is the Ramon 3 provide much higher port density. So we were able to use a single Ramon 3 chipset and be able to support up to 64 switching port, and then at 800 gig using the QSFP-DD. So this is a single chip design, and basically this port, they look like an Ethernet port, they smell like it, but they don't speak Ethernet. They do the cell switching based on the Broadcom format from this box back to the red port on the right hand side on the Jericho. I think Ryan from DryNet also talked about on his slide. It's all having the backward compatibility in mind. So the fabric is capable of supporting some of the older generation of the DDC. So if we are building a brand new cluster using the latest and greatest feedback fabrics, this fabric can be backward compatible with some of the older DDC standard, and we'll be able to have a mix and match with the Jericho 2, Jericho 2C+, and also the Jericho 3. So the backward compatibility is very important for those customers did not have the greenfield. And Shivakuma, if you can go to the block diagram, and I can talk about this really quick. All right, great, thank you. And then this is basically the block diagram of the Ramon. It's a single Ramon chipset right in the middle. And then we continue to cookie cut the same utilization of the control plane on the left upper corner, the Intel Skylake, to run the network operating system that we partner with DryNet. And then in parallel, we also use the same BMC controller, the processor, to do all this housekeeping and whatnot. I just remember one thing that this Suvakuma, I just remember one thing. If you can go back to the J3, I think it's something important that I forget to mention. The J3 slides, the front panel is fine.
Front panel?
Yeah, front panel, right. So at the beginning of the call, Suvakuma mentioned that we are building 2 versions of the J3. And sorry, I forgot to mention. The one you are seeing here is based on QSFP-DD. And we are also building another one that is based on OSFP optic. All right. For those of you who are interested, OSFP is slightly bigger than the QSFP. So what we are learning is the industry is migrating one to the other, but doing this, cross intersection, what we are learning is for some of the carrier environment like AT&T or whatnot, they've been using QSFP-DD for so long. So that's why we are providing a version on the QSFP. There's also some migration on the industry utilizing the OSFP, which we have another J3 boxes that utilize the OSFP. OSFP is slightly bigger, so the port density is a little bit lower due to the real estate on the front panel. If you take a look at, if you have any opportunity to look at OSFP optics, a lot of the data center like Google and those, or even some of those mega scale data center, they do use it, and they tend to be a little bit bigger. If you have an opportunity to look at one physically, it's actually a heatsink built-in to dissipate heat natively from the optic itself. So for those that doesn't need like super long distance like a carrier using the CR or CR plus on the QSFP, the data center side, Ran mentioned about some of the application on the Jericho 3 for the AI and all that. They don't need distance. They just have like a downlink into the GPU farm. So those tends to use the OSFP. So I just want to share with the audience as we are migrating in the industry, we as a hardware company, we are covering both directions, but I'm sure in 6 months, a year, we will see a much clearer picture which CAM actually has more users on those. So that's on the optics side. All right, Subakuma.
This might be an obtuse question, but is there a way, I mean, you were kind of showing the diagram on slide 10, is there a way to set up like a mirror port at all, like where you could basically get kind of a read-only copy of what's being sent and
Yes.
received?
Yeah. Right. Yeah, that is called a spam port. Yeah, basically it's pretty much a software function. The hardware is capable of doing so. In fact, we've been doing that for some time. You can plug in like a protocol analyzer on the spam port. So with port 0 and port 1 are switching traffic, and then you set up a spam port, and then you can mirror all the traffic into the spam
Right.
port into a protocol analyzer. You can do your troubleshooting and whatnot. Yes.
Yep. Okay, so that's basically kind of a software setup. So you could, it's not like a dedicated thing. You can kind of use any of the
Right. Yeah.
ports for that. Okay, interesting. All right.
Yeah. So, okay, Super Kuma, anything else you would like me to cover? Maybe the comparison table on all the
Comparison
NCP?
table you can cover on the NCP, and NCF will cover the cluster topology. I will do it. Yeah, go ahead.
Okay, that sounds good. All right.
Excuse me. I have a question. Can you kind of explain the service port versus the fabric port? What are the
Oh, sure.
functionality differences? Thank
Oh,
you.
sure. Yeah, no problem. If you can go back to the slide on the NCP, let me talk about the service port. It's the
Oh,
one above the Intel.
you mean the
Yeah, this is fine. This is fine. Okay.
Yes.
So
Okay.
to answer your question at a high level, we color code them. And so just to recap what we talked about a couple of minutes ago, the DDC cluster is based on the architecture of doing packet switching to cell switching and then back to packet switching. And we believe all the white paper has been written mathematically, this is a more effective way to switch traffic than the regular spine and leaf, even though you are using the 9K jumbo frame. All right. So that's kind of and if you look at some of the OEM vendor like Cisco, you look at their CRS platform, the carrier routing platform, they do employ the same architecture, packet in via Ethernet, then they do a cell switching on the back end, and then coming out on the other side, they put all the cell back together. So mathematically, there's been a lot of white paper written that's more efficient to use the uplink and downlink bandwidth. So that's the fundamental. Okay, now we covered that. So what you are looking at here with all the port is the following. The one with the blue on the left-hand side, the 18 800K or the 36 400K if we want to do the breakout, all these are network port. You can plug in regular, they talk Ethernet, either the 1500 byte or the jumbo frame, the 9K, and those are just, basic network switching. The color code on the right-hand side, those are fabric port. The Jericho 3 itself, the chip itself, has the intelligence to basically break down the Ethernet packet and put them into a Broadcom-specific cell format. And then I was told it's like a 256 byte, if I remember that number. And then the red port on the right-hand side, they go uplink to the Ramon. And then the Ramon will switch the downlink to another J3 or J2 devices into the red port, which is the fabric port. And then the J2 or J3 on that piece of box will put all the cell together back into an Ethernet. And by the way, that's the reason on the specification, the cluster on the uplink and the downlink need to be kept within 100 meter I'm not sure if J3 has increased the distance. The 100 meter has a lot to do with the fragmentation and the reassembly. So that all the cell, when you break it down from an Ethernet packet, they come back on the other side within 100 meters. So the timing is being calculated. All the cell will come back in time. So the Jericho data plane can put all the thing back together and make it look like the Ethernet frame. And then somebody asked a question on the micro USB. Then we have the management port and the console port. Those are more or less for our field engineer. When we're on the field, we can do some troubleshooting, things like that. One thing is worth to bring up, and whoever asked the question, thank you. I think it was Eric. Thanks, Eric, for bringing this up. I forget to mention. You see some of the SMA connector, the small miniature connector on the left upper corner, on the left-hand side. Those are the one that actually for clocking and timing. So, we support some of the legacy, like the 1 PPS, the 10 megahertz, and all these other things. So that's for the timing. And not to confuse the PTP we spend a lot of time to talk about today with the Grandmaster, the boundary clock, and the transparent clock. All those are coming through the Ethernet. Usually, the Grandmaster will be sitting in a central office location, going through the Ethernet infrastructure to deliver the PTP information through the regular Ethernet connection. And what you see on the left-hand side, those are some of the legacy timing. I would say majority of the time, the customer don't use it, but we want to keep it there for backward compatibility, for lab testing, or for legacy kind of purpose. So that's kind of a
So the fabric ports, those are for like linking multiple of these together. Is that correct?
correct. That is correct.
Correct.
And I think
So
Shivakuma is going to.
would you do like
So
20
here
of
is
them, or are they like redundant?
no, hold,
Like, so you could
yeah.
do 10
So
total with 2 redundant
I
connections, or
I
could you
just
do
I
20?
just switched the slide to this particularly. Maybe you can explain using this diagram, Kai, if you're making an effort. So
Sure.
these are the NCP files, right? Here you can see my slide. Maybe it takes some time to come to you guys.
Yeah,
I'm
we
showing
can see it.
DGC version 3. Yeah. So the bottom row, what you have is all NCP files, right? There are 64 NCP files you can connect. So how do you connect? The fabric port, what Kai described will go, look at my arrow, it will go to the NCF. NCF is the fabric. So everything is going to go here. So basically this table is going to tell you how many NCFs and how many NCP files can cater to. For example, if you see the last row, 64 NCP files, if you use, you need 20 NCF3s fabric. There are 20 fabric ports here, so you can use maximum of 10 NCF3, which in turn gives you total capacity of 922 approximately. So if you use a less number of NCP5s, we do that, calling it a large, medium, and small in AT&T. So this is a large cluster. So large cluster caters to 922, and this is how it is deployed here. So maybe connectivity diagram helps little.
Yeah, that's good. Thank you.
I will add, I think one thing which I think is worth mentioning or being more explicit about, it's not that the traffic is selecting a specific NCF to go through. It's going through all of the NCF. Now, you can build a cluster with a level of redundancy, meaning that one additional NCF can then be inserted into the topology, and in the case of failure, you will still have 100% bandwidth. Okay, it's a topology decision. You can build the cluster undersubscribed exactly 100% or oversubscribed. It's all within the decision of the end customer eventually.
Thank you, Ron. Perfect.
Yeah, thank you for the explanation.
No problem. So we are going back to comparison chart. Yeah.
Right. Okay. So one last thing, Suvakuma, you don't need to go back, but I just want to make a general comment for Eric who asked the question, or John. The whole idea of the topology that we just described is mainly for one main reason, and the scaling is horizontal scalability. So it's kind of like a pay-as-you-go model. You can build a very small cluster. As the traffic increase, we add more fabric, we add more line card, and you only need to spend the capital on the size you need at the moment, and then they scale horizontally using this thing called the CLOS architecture, CLOS. Basically, is one to many. All right, I think we have 2 minutes, so let me quickly talk about the comparison chart of the NCP. Now, today we bring to the audience with the DDC version 3, then that may imply there's a V2 and then a V1. So some of these older number, the NCP 1 and 2 and 3 and 4 were kind of like the legacy one that we have built over the last 2 or 3 years. And now we are on the NCP 5 that we focus today is again based on Jericho 3. If I may call your attention right in the second line from the top, and that is really the switching capability. So you kind of can imagine overall, we built the first generation based on 4.8 terabit per second, and now this device is up to 14.4 now. And we are only talking about a few years of the evolution. And as I mentioned earlier, Jericho 2 on NCP1 is a 16 nanometer. Today, we are bringing to the table with a 5 nanometer chip, and all that. And then on some of the bottom, on the comparison, we listed some of the port configuration, like to call to the audience on the NCP5 we highlight that particular column. Basically, you can see there's a high increased number of port, both on the network port and then also on the fabric port. Last but not the least, on the bottom, on the timing, you can see the NCP5 with the enhancement for Broadcom. Now we can support cluster-wise PTP. BC is boundary clock, TC is transparent clock, and then also the Grandmaster. And if you look at it from some of the earlier generation, like a 1 or 2, those things were not being supported as we gradually develop the requirement and also the circuitry on the timing module from Microchip, Microsemi. And one last thing I think is worth to mention is on the bottom, very bottom on specific feature. On the top one is called the TCAM. That's the content addressable memory. This thing can be using at the core of the MPLS, which TCAM, ACL, routing table exchange might or might not be that important. If you are using at the edge, today we are presenting at the telco edge meeting. If you're using this at the edge, like a provider edge, like a BGP peering, that kind of application, you do need a pretty large TCAM table. So all these devices on the Jericho, they are equipped with some of the external TCAM. And NCP5 with the latest design, we've as a lot of these content addressable memory has been built in as well, right? And then on the last three, some customer care, some might not, and those are the security encryption, the layer 3 IPsec, the layer 2 MACsec, and all that. So for those customers really will need those kind of things, the hardware natively will support those. And then of course, MACsec, we can do it layer 2 in hardware. IPsec, we do it in conjunction with the our NOS partner as well. So that's conclude the comparison. I think I'm 2 minutes over, so I may turn it back to Suvakuma or maybe to the host.
Yes, so let me just quickly, do you have 1 or 2 minutes more, please?
Sure. Take as much time as you need.
Oh, okay. In that case, why don't you cover Kai NCF also comparison?
Sure. Okay, thank you. I'm sorry. You would you like me to do that? I want to make sure.
Yeah, you can.
Okay, all right.
You can.
Okay, sure. Okay, no problem. So today we brought to the table of the what we call the NCF 3. NCP stands for Network Cloud Platform, which is the line card. NCF is the Network Cloud Fabric. Those acronym. As I mentioned earlier, when I shared the block diagram on the fabric design, the NCF in the middle is using the first generation of the Ramon switching. That's a Ramon 2. We are skipping that. We jump directly into the Ramon 3. And for the purpose, because the Ramon 3 can provide much higher capacity. In this case, if I can call your attention, right in the middle of the port configuration, we can support up to 64 port of the fabric port switching at 800 on a single chip, as compared to the existing NCF. We support up to 48, but that is a dual chip design. So the old Ramon is a dual chip design versus this one is a single design. And last but not the least, on the right bottom corner, you see the list of all the timing. Now with Broadcom's enhancement, I talk about doing the packet fragmentation and reassembly from packet to cell to packet. Now we can deliver the PTP traffic. So we continue to support end-to-end using this newer chip on the boundary clock, transparent clock, and whatnot. And so those are the enhancement of the cell switching support from the older one. All right, so I'll turn this back to you, Shivakumar.
Thank you. Any questions? If not, I'm going to cover optics. So optics is also very important. As you know, 800 gig is being introduced, and we need support for 400 gig and also other speeds. What we are listing here is only generically tested available optics. We call it third-party optics, but we are not listing any of the vendors here with the intention that we don't want to promote one over the other. But in general, what I want to say is these are the optics tested, working fine. The vendors list are available. More than one vendor list is available with us. And also we have asked our partner UFI to really test various optics and make sure that it is working, compatible, is it conformance to the specification, etc. We are taking care. But the only thing what we are not listing here is the name of the vendor for obvious reasons. Anything? Any questions on the optics? If not, I covered already the cluster design. As our partner, DriveNet NOS partner, told, even though we have all this combination available, one more point to be noted is it works with the older version of the NCPs also. So when we use a different combination, why I'm bringing that is, if you already have an installed base, only if required, somebody wants to take a decision to only introduce for 800 gig 6, some NCP 5s, etc. they can do. So the mix and match hybrid condition is allowed from the NOS also. But what we are listing here is if you're purely considering Jericho 3 and Ramon 3, then this is the table. But other conditions do exist.
I do have a question. With all these high power, 800 gig optic, whatnot, right? If it's fully deployed, can this box still use air cool? Does it have to use like cold play, liquid cooling type of thing?
This box is still air cooled.
Yeah, go ahead.
Yeah.
Go
This
ahead,
box is still
Kai.
Yeah. This box is still doing air cool, Eric. Although the thermal design we had to really play around a lot in the chamber in our facility back in Taiwan. But we were able to build this with regular air cool.
This is 2RU
Correct.
chat.
This is 2RU. Yeah.
Yeah. Eric, if
Thank
you are planning to come to the OCP summit, I believe we are actually partnering with our partner and have a cluster there. We're still working out the logistics, but if you come, please come see us. I do believe we are actually showcasing a cluster we are building at the OCP summit.
Okay, great. Yeah, I'll be there. Thanks.
All right.
Yeah, there is a NCP5, what's called NCP5, going to be on display at the OCP summit.
Right. I think I will see you again, Ryan.
Oh yeah, absolutely.
Yeah.
Yeah, Ren and I used to
So
do the lightning talk at OCP. Okay, back to you. We are 10 minutes
yeah.
over.
So yeah, DDC compliance, right? So it's a compliance. I have a good segue to the compliance section. So as you can see, AT&T standards and like we follow this TP numbers are all written here. So I'm just saying whatever is our central office telco standards, NEPS level 3, it is compliant. They're going to really build based upon that only. These are the operating temperature, and there is a height is 2RU, depth, everything is written here along with the clocking, etc. So most likely all the compliancy like before is met by this particular product. I think with that, we covered all. That is it. I'm covering everything. It's done. Any questions?
I'm sorry. What the software OS you're running on this box? You support it?
So currently, for there are applications in AT&T. We have P core applications. That means core applications. We have DriveNet as a NOS.
I'm sorry. What net?
DriveNet is the name of the company.
Right.
The
Oh,
gentleman from Run gave us a brief on their features. You remember this particular slide? So that is from DriveNet. But just to tell, if the same functionality in the like Jericho 2 boxes, same DDC cluster being deployed in the edge, we have Cisco as the NOS there. But this particular presentation is only about the version 3 Jericho 3P core. So we are only talking about DriveNet as a NOS.
There are multiple
Okay,
options for NOS to run on DDC. In this case, we're talking about DNOS, DriveNets, NOS, but other options, as Shiva Kumar just mentioned, Cisco is one of them. There are others as well that can run on these devices. You know, it's an OCP, so definitely there's more options.
Yeah.
Hey, sure, Kumar, a quick question. Here it's showing this one is for last year, and then I saw on one slide you mentioned AT&T has submitted contribution for presentation on global summit of OCP. So are you means the coming OCP or last year OCP?
And one more time. So what is the question? Repeat.
Yeah, the question, if you look at this one, well, actually on the bottom bars, it's showing last year's date. And then in one slide, you I think that the one before this one, you showed AT&T has submitted contribution to be published or to be presented in OCP. So do you mean this one has been shared and presented already last year, or it's going to be done?
No. So let me go to that section. Maybe you're talking about this
So
one, right?
hang on a second. Tanji, they did present at last summit, but it was not DDC v3. This is a new submission that'll be presented during the presentation at OCP this year. And I believe I just heard that they will also be having the physical implementation so that you can take a look at it at this year's summit.
Sure, got it. Also, it's confused with the bottom part of the date.
Yeah.
I think
So
he's just using
take
last
a
year's
look.
deck.
Just the template.
Sorry.
Just the template for this.
Sorry. This slide clearly says in 2020 we gave the first version of Jericho 2 DDC presentation. In 2022 we gave a version 2, and we just said what are we doing here, etc. So if you look at that presentation, you will know all the details of last year presentation. Now in 2023, which presentation has not happened in the OCP Global Summit, when we cover, this is what we are going to do. So year-wise, I've mentioned here. Yeah.
Thank you.
Okay. I know a lot of moving parts on this, so I tried to think what can come and then I captured everything. But still, in case you have any other doubt later on, please shoot me an email. We can clarify and improve this particular deck before we really, submit it to the global summit, right? That deck, you're open for suggestions.
Looks pretty good, Shivakumar. You covered it all aspects, so that's really good. You'll always struggle with the time you get for such a lot of content, but either way, I think you've covered all aspects of the version 3. That's good.
Thank you, Ripin.
Any other questions? All right. Well, that was a fantastic presentation. Thank you, team. Very, very interesting. I appreciate everybody's patience. I know we ran a little over time, but I think this was good, and look forward to seeing this at the Global Summit there, because this is some pretty interesting stuff. Any other last minute things? Otherwise, I will call our meeting to a close, because we are over time, as we said. And anybody else got any last minute questions?
Thank you to all the partners and all the vendors and my partners in crime to come and then present this. It is really a joint effort. We'll continue to do the same thing with OCP folks in Global Summit and make it a big success.
Sounds great.
And thank you, Shivakumar.
Thank you, Shivakumar.
Sure.
All right, everyone. Well, then with that, I guess we'll call the meeting to a close.
Thank
and
you.
Look forward to talking with you all next month.
Cool. Here's everybody.
Talk to you later.
Thank you.
Bye-bye.
All right.
Thank you. Bye.